So there's an equal sign here. Now, if I multiply, 3 times 4 is 12. Divided by 4 is 3. So this really just simplifies to 3x. We got rid of the fraction. And over here, those x's will divide out, and I just have a plus 4. Now we're back to a quadratic like we've been doing. Okay? What do we need to do first here, though? Yep. How did you decide to choose this side to move? Good. You want the x squared term to stay positive, so I'm going to move everything else towards it. So it's going to be 4x squared minus 3x minus 4 equals 0. Yeah? Now we have a trinomial. Let's see if it will factor. So we have to multiply to be a negative 16, but add to be a negative 3. Does it work? Factors of 16, what? 2 and 8, 4 and 4, 16 and 1. Any of those combined to give me a 3? No. So we can't factor, bro. What are we going to do? We could do quadratic formula. Could we complete the square? Nobody wants to complete the square. And here's how you know, guys. If this middle guy is odd, you don't want to complete the square. Can you? Yes, but it's a hot mess because there's tons of fractions involved, and we don't want that, right? We know we have multiple methods. Factoring, completing the square, extracting the square root. Can we just take a square root from both sides? This one doesn't fit that format, does it? No. So then we're just left with quadratic formula. So let's just do quadratic formula on it. Making sure we know our quadratic formula, right? All right, so remember, it's negative b plus or minus b squared minus 4ac all over 2a, right? Be careful. On several people's tests, last time I saw a plus sign right there in the middle. It's a minus, all right? So let's do this. So negative b would be a positive 3. B squared would be negative 3 times negative 3, which is 9. Minus 4 times a, which is 4. Times c, which is negative 4, all over 2 times 4. Okay, so let's clean up. 4 times 4 times 4 is 64. But I got a negative times a negative, so that makes it positive, doesn't it? So I'm going to be adding. So what's 9 plus 64? Yeah. 3 plus or minus the square root of 73 over 8. Is that going to reduce? No, it is not. 73, not even divisible by 2, is it? So we're going to leave it just like it is. Are we good with that? Wonderful. The excitement is so real. All right, let's look at number 2 here. We're going to start with the same idea. What is going to be our least common multiple here? That we can multiply through the whole thing, and x will cancel out, and x minus 1 will cancel out. What were you going to say, Jazzy?
Alex is going to say.
Alex, what were you going to say through Jazzy?
X parentheses x minus 1.
How'd you get that? Yeah, she just put them together. That's fine. That's fine. Sometimes that's the easiest way to do it. So I'm going to be multiplying everything. I'm distributing that to every term. So 3x times x minus 1 all over x equals. I'm going to put that x minus 1 in parentheses. Now let's see what we'll clean up, what we'll cancel out. Over here, the x's go away. Maybe I should use a different color. Those go away. So now I have 3 times x minus 1 equals?
3x minus 1. Oh, minus 3.
Yeah, but over here, I'm going on the right side real quick. The x minus 1's canceled. Do you see that? What's left over is the 5x. Over here, nothing's going to cancel. I just need to do some multiplying. All right, now we're going to do this distributing piece. Let's distribute the 3. 5x plus 7x squared minus 7x. That's a lot of stuff going on in it. Now we're going to collect like terms, keeping x squared positive. It's positive on the right, so we're going to leave that on the right. So 7x squared. We're going to have to move this 3x over, so it's going to be minus 3x. So what are we going to have? Negative 5x when we combine all those. Negative 7 minus 3 plus 5 leaves me with negative 5. And then the minus 3 over here becomes a plus 3, so it's going to be plus 3. All right, trinomial, quadratic. Let's think through our stages of solving. Can we multiply to get 21 and add to get a negative 5? What can we use? 7 and 3 are my only factors, 21 besides 1 and 21, right? Those do not combine in any way to get to 5. They're close. They get to 4, but they're not quite there. So factoring's out. I don't want to complete the square because the 5 is odd. Square roots are not part of this, right? So we're going to do quadratic formula again. All right, let's do this. So negative b plus or minus b squared minus 4 times a times c all over 2a. All right, let's figure out what's going on under the radical here. We've got 25 minus 12 times 7 is 84. I don't know what that is. 25 minus 84.
It's 84.
Well, but what's 25 minus 84?
Oh.
Negative 59.
Oh.
That's what I was going for. Negative 59. All right. So now I have 5 plus or minus the square root of negative 59 over 14. Am I finished?
No, you said negative, so it's gotta go in front of the square root as I.
We're going to pull the negative out as an I, right? So I'm going to end up with 5 plus or minus I square roots of 59 over 14. So kind of gnarly, but not impossible, right? But it all started with this least common multiple step. That's what these questions today, how they're differing, okay? So try them out. Whatever you do, do not stay stuck, because that's not the place to be, all right?